he's probably going to be a minute late. So while you guys are adjusting that, so what we do, I've got a co-host that will be joining here, I think, shortly. But typically, what we do is we do a 1 hour podcast. It ends up splitting into 2 episodes that we do a little bit of editing and things like that. So they run about 25 minutes a piece. It's video and audio. So we do the audio. The audio podcast is sort of within the video version. So we have some preamble, green room kind of stuff that we have before we dive into the audio podcast that people on YouTube get to see. And then afterwards, we have a bonus, sort of bonus section that we'll ask for, a challenge or, next steps that maybe you would, suggest to somebody, to our audience based on what our discussion is. Or if there's one, words of wisdom or something that you guys have. We do an introduction. I'll introduce myself. I introduce Michael. Let you guys introduce yourselves, and then we dive right in. It's very organic. Our audience are developers, entrepreneurs. Typically, it's actually the developers that have that most of your good developers also have some sort of a side hustle, entrepreneurial bent. Anyways, they're solving problems, and so those are the people we're talking to. The specific thing that I really want that got you guys invited was a different discussion with somebody else, and I can't remember who initially connected all the dots for us, but was actually talking about certain technologies that would be recommended to newer developers or developers that are learning certain languages or something like that in the world of AI, where I think you guys probably agree is the language itself really is sort of disappearing as mattering as much as understanding how to develop software. How do you actually build good software and the pieces around that? Bonus for you guys, we have never had 2 guests at a time. So this is going to be a whole new thing. So we'll see how this one goes. So when we ask questions and stuff like that, you guys can feel free to go back and forth. When I do the introductions, I guess I'll start with Bob because he's on the top of my screen. I'll do Bob first, and then you introduce yourself. Jim will introduce himself, and then we'll dive in. Clear as mud?
Sounds great. Yeah. Thanks. Awesome.
All right. Michael, audio all good?
I'm going to turn off my air conditioner real quick.
Okay.
Let's be right back.
All right, try again, Bob.
Hey, Michael.
Okay,
Good to meet you. Can you hear me?
Yeah, you're soft compared to Rob.
Oh, weird.
I can turn it down a little.
If you turn yours down, Rob, then I think that will balance it.
Let me see. Where did that? Oops, that is
I'm as close I can get. So, is that good? Is it, or do I need to adjust my?
No, you're coming in clear. I think the reason I'm doing this is sometimes if Rob's louder than everyone else, when it records it, I can't balance it. I have to go find all the places Rob talks and
my
tone
input
them down.
volume is low. Is that better? Is that a little bit lower?
Yeah, that's much better.
Okay. It's funny.
Jim,
my
can you
input's
do a
almost
quick sound
zero.
check?
Yeah, how do I sound? Sound okay?
You're awfully soft.
Awfully soft.
Just pull it a little closer.
Yeah, I might need to speak closer to the mic.
That's better. Rob, is that good for you?
It's how are you hearing it?
It sounds okay now for me. I just want to make sure it's the same for you.
Oh yeah, I'm going to be good anyways. I'm not as picky as the editor is, as the audio editing stuff. So, all right, if we're good, let's dive into it. 3, 2. Well, hello and welcome back. We are continuing season 28 of the Developreneur Podcast, Building Better Developers. I am Rob Broadhead, one of the founders of aforementioned Developreneur Podcast. Also the founder of RB Consulting, where we help you avoid the costly mistakes of technology sorts before you make them. Good thing and bad thing. Good thing is we've got two guests today instead of one. The bad side of that is we've not done this before, so we'll see how well this goes. This could be a train wreck in the making, but no pressure on anybody's part whatsoever. Also good is Michael is here to take the blame if it goes wrong. So go ahead and introduce yourself.
Hey everyone, my name is Michael Meloche. I'm one of the co-founders at Belpreneur, Building Better Developers. I'm also the founder of Vision QI, where we create reliable, tailored software that helps you work smarter, scale faster, and stay in control. Good thing, bad thing. Good thing, we've got two guests. Bad thing, I was in the waiting room waiting to join the meeting, and it kicked me out. So I had to rejoin, which is why I was a few minutes late.
And number one of those guests, Bob, go ahead and introduce yourself.
Hey everybody, I'm Bob Belderbos. I'm a software developer and coach. I've been writing software for 20 years. I've originally a finance background, so it was a lot of Excel macros. And I got intrigued by joining Sun Microsystems, doing Unix support. And I got in touch with scripting and automating things and never looked back. Went into Python in 2012. And recently in 2024 went into Rust. You can partly blame Jim for that, but I'm actually really happy that he nudged me toward that stricter compiled language. So I'm now juggling the two, Python and Python and Rust, and that's what I do, helping people every day. Interesting times now with AI, but nonetheless, getting people upskilled in building better software.
Excellent. And he alluded to our other guest, Jim. Go ahead and introduce yourself.
Yeah, hey everybody, I'm Jim Hodapp. As Bob said, we've been working together, but I've been a long-time software developer too. Got started actually early from my father, who was into software and engineering when I was 10. So, and I'm not old, but I'm not super young anymore. So it's been a while, and a long-time C and C++ developer. I studied computer science, electrical engineering, so that's why I fit in there. That world for a long time, systems programming with Linux, and worked at a bunch of different companies as a software engineer and engineering manager for a long time. Developed a lot of software, and then in 2020 I got introduced to Rust from a colleague of last company I worked for, and I've been looking for something to replace C and C++ for a long time. I knew it was like right on the cusp. There's all kinds of good language innovation going on. And I gave it a shot, and I loved it right away, and I never looked back. Immediately, both languages felt dead to me. So the rest is history. I'm a genuine natural evangelist of it. It's just an outpouring of my love for it.
Excellent. And that's where we're going to spend some time today, is some evangelizing. I'll touch on a couple things from the intros there. I haven't heard the word Sun as in systems in quite a while, but actually loved those. We had plenty back in my college days. I loved the little Spark workstations and stuff like that. Did more than my share of C and C++ in the Sun world back in the day. C and C++ have been dead to me for a very long time. There was like some good things I liked, but I found Java back, 30 years ago now, and I was just like, okay, I can get away from the things that I didn't like, mostly the pointers and the stuff related to that, which was cool when it was useful, but not so much cool when I got stuck into it. But that leads us into with a great background. Both of you guys have got pretty solid, I'd say solid developer bona fides coming from a couple different areas, but embracing Rust. And it is, I think it is definitely, we'll call it an up and comer kind of thing. I've definitely seen that it's not like just out there. I know there are plenty of Rust developers. I think it is one of those that is growing. And I'd love to start with we'll start with the easiest thing is, I guess, is like, what attracted you to Rust?
I'll start with that. Very similar things that initially attracted me to C and C++, which, for me, I love the expressiveness of Rust. To get exactly what I want. It strikes the right balance of control versus giving me things that are high level, right, that make me more productive. And it rewards me for investing in learning its structure very well. Right? So understanding what is really good idiomatic Rust rewards me with really good performance. And I don't know why, but that's always been something I really appreciate. When I've worked with other languages where, you do something really, really cool and it feels a little sluggish, That's just not as rewarding to me. So like my C++ replacement had to be something that gave me that kind of performance, and Rust does. So it doesn't punish me. In other words, I can get the most out of my hardware that I run it on.
Cool. Yeah, and I have a totally different entry level because I'm a Pythonista. I'm spoiled. I can just quickly write up a script, but all of a sudden you start to realize that Python can also be slow, and it can be tricky. For example, when you have non-values in your program and you don't, catch it at compile time and it blows up in runtime. So in 2024, I was at PyCon US and I saw Charlie Marsh give a talk about Rough, which is one of the linters, or the linter now in Python land. And he was talking about the stack and the heap. And yeah, I took it as a challenge, like, hey, I need to learn a new language. I need to up my level as a programmer, right? And Rust gave me that challenge to look into memory management, look into more advanced things that could get me beyond the typical scripter level. So I did a month of Rust, writing a blog every day, and got the basics down. And then, yeah, I was still a newbie because there's a lot to learn with that language. But yeah, over time, I've really grew a passion for it because of that strictness. Because of Jim, I think it's called zero cost abstractions, where you can write very
Correct.
expressive code, almost like Python-like, while getting the performance right. But I think for me, the performance, well, that's actually what drives the trend in Python now, that all these tools are getting rewritten in Rust for the performance. For example, the core of Pydantic, and we have basically cargo for Python now with UV. But yeah, the side effect has been that it also made me a better programmer of this, because of the strictness and the exhaustive checking that is in Rust, and having a beautiful compiler that really helps you. And yeah, now I cannot unsee that in Python anymore.
Well, I think that it's interesting that the path that you came. It is, Python has become very popular, I think, partially because it's the good and the bad. It's like you can crank stuff out very quickly. It's got a very large community, but the whole cranking out very quickly, part of it's because it doesn't hold you to a lot of, it allows you to have a lot of bad habits, and still it like finds its way through it. It's actually, in the world of AI, pretty fun, because it's like that's exactly the same thing AI will do. It can go crank something out, but it's not necessarily going to be something that you want to hit prime time with. And I think we'll go right into that, because it's, in the modern world, AI assisted development is very much a thing, across industries and things like that. And I'm wondering how Rust, being a little bit newer in languages, are you seeing that it has the kind of supports that AI has enough understanding of Rust to be able to help you out, particularly with we'll call it the pedantic sides of it, or the redundant sides of building out some of the structures and things that you always, you have in any language, where it's not really leveraging the language. It's just really saying, okay, I've got to do this, and it's going to be repeated 10 times because that's just part of talking to the computer. Are you seeing that AI is able to support that and be able to work with it? Or is it a point where it's like, if you're a Rust developer, you really need to just be sticking in Rust, and AI has not advanced to a point where it can help you out?
Yeah, that's a great question. I think in the earlier models, that was true, that it wasn't quite there yet. So that maybe the early 4.x versions of Claude, for example, that's what I work with the most myself, primarily. So most familiar with that. But yeah, it would write, you could tell, like, compared to TypeScript, which is something I've been working with a lot lately too, it wasn't quite there yet, especially when we were just in the chat interface era of AI coding. Be a little naive. But ever since Claude Code came about in the newer models, it's good. And one of the things that I started to notice, again, comparing Rust to TypeScript, working with a full stack code base with both, is that with Rust's, more strongly typed nature, right, and a lot more strict on the structure, right, and the types of things that you're working with in the language. It's a lot more opinionated and enforced with the compiler. And this actually makes up a lot for what the model doesn't quite understand yet or able to reason about, because it's in a loop, right? So it has to figure it out. It has to make the compiler and the linter happy, and it's able to do that even if it doesn't have all of the level of training that it needs in a particular kind of Rust code or structure or something like that. So that is one of the major advantages to Rust. The thing that made it hard, or makes it hard sometimes, to for a human to come up to speed in it, right? Because it takes a lot of practice, right, and experience. Because AI can iterate so quickly, right? It actually helps it produce more correct code because of that, right? So the thing that works against the human works for the AI.
That makes sense. Bob?
Yeah, I have the same experience that the models are well trained on Rust, and you definitely get better code. Now I'm still learning it, so I also lean on Jim to really give me that final review on if it's idiomatic enough. But I'm getting there. But also, yeah, I also agree with strict guidelines. Guardrails are really good for AI, right? Having the compiler less ambiguity. Like ambiguity for AI is deadly, right? So having that more stricter and forcing the model to really get it, because the compiler catches practically everything, right? If it compiles, usually it works, right? So having that guarantee is actually really good for the AI. And as a human, you would do that as well. But yeah, offloading that to the model that's getting more autonomous is a good thing. And yeah, that's where with Python, I feel I need to. The burden is much more on my experience, and you see beginners, yeah, mutability and stuff can sneak in, right? And where probably I have a feeling that Python works probably well with me and AI because I have the experience to validate it, but that has to come from the developer, where in Rust the compiler takes a big part away for you. I mean, you still have to know what you're doing, right? But yeah, you have definitely a strong pair programmer there.
Yeah, indeed. Yeah, to add to that, like in Rust, one thing that the compiler still can't quite give you that, AI creates a little slop around is it seems to be trained on a lot of procedural style code. So if, else, then kind of stuff, almost like going back to even like basic programming languages and that. So you do have to catch if you want it to write in a certain style, certain patterns of of software patterns. Actually, literally, you have to catch it and say like, hey, you're writing too much procedural code. The rest of the code base is functional in nature, and I want you to match that, right? And so that's something that even the Rust compiler can't quite catch for you, nor can tests, right? So you do have to catch that. So it's not a silver bullet, but it does give you a lot more than these languages, which have a lot of different ways of expressing the same thing. And it's not necessarily enforced at a compile time. It's enforced at a runtime correctness.
So it's interesting. We all seem to have similar backgrounds, and I have not touched Rust yet, but from what I'm hearing from you guys, it really reminds me back of my college days working on the VT100s, writing C, C++, actually writing machine language for processors. And it feels like we're going, we all know that compilers are faster. Working in directly with the compiler, directly with the chips is a faster way to code to get your things to work in a way. But you run into the limitations of you're working on a processor, right? You're kind of tied to like an OS, you're tied to like an Intel chip or an AMD chip. But and that was what the whole boom of like the Java, Python, Node, and all those, where you can write once, deploy anywhere. How is Rust work in comparison with that?
You want to try that, Bob, or you want me to take that?
Oh, yeah, you can take that one. Yeah.
Let's see. I think it works really, really well, which is what got me excited enough to replace C++ in my world, because for me, so right before I learned Rust, I learned Elixir, which is a very modern, high-level language. Right? It's partially compiled, so you get somewhere in the middle kind of speed of what you're talking about. Rust gave me like almost everything that I came to appreciate about Elixir, and working at that high level and the expressiveness. But what Bob mentioned before, the zero-cost abstractions, I still can trust that it's very optimized for whatever hardware it's running on. So it's like I get my cake and I get to eat it too. Right? So it was thrilling to me. I'm like, finally, I've arrived, and I can write this on. I can do this in web applications. I can do this in embedded programming. I could do this on anything where you can compile down to a binary, right? The LLVM, and produce a binary for whatever target, and it can run, and it's efficient, and I don't have to compromise on how I can express myself in the language. It encourages really good development. Yeah, so it's pretty remarkable.
I have nothing to add to that. I'm not coming from a compiled background, so that was a better question for Jim, I think. Yeah.
Yeah, no problem. So, yeah, one of the problems I had back in the day, and it sounds like Rust may still have this, but maybe it's more modern and capable of handling it. But back in my C and the old days, you had to, with like the Intel processors, the AMD chips, the Linux chips. It's just one of those issues where you then start running into, you have to start managing the different you kind of have to be choosy on where you're deploying your software, right? It's like, are you going to stick to an Intel base? Are you going to stick to an AMD base? Are you, it just, the deployment of the software gets to be a little more tricky, right? Do you still see that with Rust today? Because I know in the past it's like, oh, I have to make sure I deploy to this 32-bit, to this 64-bit, to this. Am I making? It's really hard to articulate because it's been a long time since I've had to get down to that level again. Because when you deal with wrappers, it's not. It's again, you write once, deploy anywhere, but you lose that. Like you said, you lose that capability of really the refinement of getting the machine speed, the performance that you want from the application on the device.
Yeah, that's a great question. I would say there is a slight difference, but it's not like it was, like as punishing as it was back when you're referring to, because that was hard, right? Cross-compiling, you could call it, or something like that. That was a pain, and you didn't always have a reliable tool chain to get you there too. So you had to always like go and find your tool chain. Now today, though, Rust and Cargo in particular pretty much abstracts all of that. It makes it very easy to set your architecture target. Again, you have to think about it as you're setting up your project. Right? What architecture are you targeting? And you got to set up essentially your build process and your CI/CD pipeline to output those artifacts for that. But once you've got that, you're not thinking about that. Right, so it's part of if you're starting from scratch, you got to set up your container runtime anyway. It's just part of that. You do it once, right, and then you keep developing. And if you bring in a new kind of architecture target, it's not that bad, especially with AI. Its ability to add that very quickly, right? So like take what I have for ARM64 and add it for MIPS or whatever. Yeah. So the scary aspects of that are gone, and you don't really even need to understand the details of that anymore, even as an engineer. You just need to know that, like, I'm targeting this architecture because the device that I'm targeting, if it's embedded especially, is that, and that's it. So not quite as flexible as like a JVM or something like that, but not far off.
But you're finding that the AI tools, though, are helping. That basically AI understands Rust enough that it can help you build those environments quickly and help you set that up so you don't have to really waste too much time learning that aspect of it. It's like, oh, here, build me this, and you're jump in and start coding.
Yep. You just basically need to understand it from like a single digits or tens of lines configuration of cargo or GitHub Actions or something like that, and set it up and check it in and make sure it runs and forget about it.
Yeah, and as a testament to Cargo, right? Like packaging distribution has always been a pain in Python with dozens of different tools, and now with Astral bringing that forward, all Rust-based with UV. As I said before, we basically have a Cargo for Python now, and it's very popular and widely adopted because it's so ergonomic and fast. So yeah, it's a big win. Astral has redone the tooling in Python in Rust.
And that is where we're going to pause. So far, so good. We've had more people on camera than we've ever had in the history of Developreneur that I know of. Well, I guess other than the live events when we had other people in the background, but more. I guess not more direct. That was like the one time that we had like the live and had a few extra voices, but they weren't all at the same time. So this is new, groundbreaking. 1,000 episodes it took plus to get there, but we got there. But I digress. So we're going to wrap this one up. We will be back. We're going to continue the conversation. If you aren't itching to try Rust yet, come back next episode and you will. If you do not have time or bandwidth to learn anything new, then you just bail out right now, because this is one of those that I think I'm going to challenge your developerness, your geek card or whatever it is, of like, this is one of those episodes I don't think you can listen to it and not have an itch to go learn that other language if you don't already know Rust. If you do, I'd love to hear your feedback of like, what have you guys seen as well? How much resonates and how much have you seen maybe some differences in your experience with Rust? As always, though, go out there and have yourself a great day, a great week, and we will talk to you next time.